Hello everybody. Today we're going to look at calculating gravity or weight of objects on planets. Earth, Mars, Venus, Jupiter, Pluto, some other planet somewhere else. Oh, cool. Now, the formula for finding gravity or weight on a planet is gravitational force equals mass times the gravitational acceleration, or the acceleration due to gravity in free fall, okay, on the planet. Now, if we take our information, we can use a triangle to help us determine what to do, okay? For example, if they don't want the force, what if they want the mass or the acceleration? What do you do mathematically? Well, remember we used a triangle for speed. Well, we can use one for gravity also. So right here, whatever you want to find, you're going to cover that up with your finger and then look at what's left to see what to do. So for example, suppose you want to find the force. You cover up the F with your finger and look at what's left. You're going to say mass times acceleration due to gravity in free fall to get the force. If you want to find the mass, cover the mass up with your finger and you get force divided by acceleration. If you want to determine the acceleration, you're going to say force divided by mass. So you just cover up whichever one you're looking for and it tells you what to do with the variables that you already have values for. Okay? Now we're going to do a couple of examples here, and then you'll be on your own to answer the questions and work the practice problems. Understand, now notice, right down here, on the practice problems, you must show the steps like we're going to do in the examples to receive full credit. If all you do is write down the answers, there's no way you're going to get full credit. You must show the steps. Okay, so watch what we do up here. On the first example, we have a box of mass 50 kilograms. All right, so it says mass of. So we say M equals 50 kilograms. We're going to identify everything first. On Pluto, the box has a weight of 31 newtons. So there's the weight or gravity. So we know that's F sub G, and it equals 31 newtons. Okay? We want to determine the acceleration in free fall. So for Pluto, if you were to drop something, what would be its acceleration towards the surface? Okay. So now, how are we going to find it? Well, we're going to come over here a triangle. We're going to cover up the acceleration we're looking for, and we're going to take the force that we're given and divide by the mass. Okay, so let's write that out over here. The acceleration equals the force divided by the mass. We've got those two. So that would be 31 newtons over 50 kilograms. All right, now if you take your calculator and divide, double check right now with your calculator, do you get 0.62 meters per second squared? If you do, that's correct. And oh, I should have put it right here on step 3. Sorry about that. Okay, so 0.62 meters per second squared. So that wasn't so hard, is it? You identify what you know first and identify what you're trying to find, and then determine what you're going to write down for the formula. You start with what you're trying to find and then use the triangle to see what you're going to do mathematically. Then you plug in the numbers and then you write the answer with the correct units. Notice, by the way, I did give you some helpful information. The acceleration due to gravity of objects in free fall on Earth would be 9.8, on the Moon 1.63, and on Mars 3.4 meters per second squared, because those are the units for acceleration. All right, let's look at example 2. Could you lift a car on the moon? Well, if you remember, the moon has much less mass, so it does not pull as hard as the Earth does. Could you possibly lift a car on the moon? Well, let's see. We have a car of mass 2,000 kilograms. That's about average for a car. Okay? And we want to determine its weight on the moon. So we want to determine the gravity on the moon. Oh, but we're missing something. We're missing the acceleration on the moon. Oh, but it's right up here. That's what I was just talking about. So here's the acceleration due to gravity for free fall on the moon, 1.63. So let's put that down here. The acceleration on the moon is 1.63 meters per second squared. All right. So now, since we want the gravity, we come over here, we cover up the F, and we're going to say mass times acceleration, okay? So we come back over here, we write that down. The gravity equals the mass times the acceleration in free fall. So 2,000 kilograms and 1.63 meters per second squared, and we're multiplying. So if you go ahead and multiply that out yourself, see if you get the same thing that I get, okay? I got 3,260 newtons, all right? Now, that may seem like a lot, but I'll show you something interesting here. That's the weight of the car on the moon. Suppose we wanted to look at the weight on Earth to compare. So we're going to take the mass, 2,000, and multiply by the 9.8 meters per second squared acceleration on Earth. On the Earth, this car would weigh 19,600, not just 3,260. So it is possible, especially if you have a smaller car like a little MG Midget or a smart car or a Fiat, maybe a little car. It is quite possible that you might be able to lift it or at least turn it over. You could actually roll it over because on the moon it doesn't pull as much, so things appear to be a lot lighter than on Earth. Kind of like when you get in the water, the buoyant force helps support the weight, so you don't have to support as much. So it's easier to move heavy things underwater than it is on dry land. So same idea here. Okay, so now we've done both the examples. We first identified the known information and then what we're going to look for. We used the triangle to see what form the formula was going to be, and then we plugged in the numbers, and then we got our answer with the correct units. Now, down here, you've got two definitions you're going to write out. This is to get it into your head firmly, and then you're going to answer a couple of questions, and then you're going to do 7 little practice problems, very much like what you have right here. And yes, okay, I put this information up here for a reason. You will need this information on the problems, practice problems below. They're important. Remember, these are the acceleration of falling objects in free fall on each of these planets, okay? All right, so you have at it. See what you can do, all right? Make me proud. I know you guys can do this. This is not too tough, and it's kind of interesting to compare. All right? See you later. Bye-bye.